In this video, I'm going to focus on Newton's third law of motion. There are 3 of these laws to master in the one-dimensional dynamics unit. The third law can be a tricky one, so I wanted to show you a way to look at the law that has made sense to many of my students over the years. The law itself reads that for every action, there is an equal and opposite reaction. Your textbook will say something similar when you look the law up, and sometimes this phrase is heard in everyday life, even before you take a physics class. So it seems easy to understand at first glance, but this phrasing doesn't always help us solve physics questions. To help, I'm going to show you an additional way to look at this statement. Newton's third law is about the interaction between 2 separate objects. Likely they are in contact. Let's call those objects A and B. If we completed a force diagram for object A, at least one of the forces would be provided by object B. And if we completed a force diagram for object B, at least one of the forces would be provided by object A. According to Newton's third law, these forces are equal in magnitude or size, and they are opposite in direction. Let's take a look at a quick example. Maybe a person gets mad and they punch a hole in their wall. The interacting objects here are the person and the wall, so I will label them A and B. A for the person and B for the wall. The obvious force in this interaction is the punching force on the wall by the person. This might create a hole in the wall, but the counterforce would be a force on the person by the wall. This would be why the person's hand hurts. So notice that we have a force A on B and also B on A, and this is how Newton's third law works. Here, looking at an example more specific to what you might see in a physics class, we have a red box resting on a brown table, and the entire system is at rest on the floor. The goal is to complete a force diagram for both the block and for the table, and then we're going to try to use our force diagrams to pick out forces that may adhere to Newton's third law of motion. Let's start with the block. I can think of 2 forces that act, an upward normal force from the table and a downward gravitational force from Earth. These forces are equal in size since the block is at rest and not moving up or down. Maybe there is a student observing this force diagram, and they make the following claim. These 2 forces are equal in magnitude according to Newton's third law of motion. Do you agree with this claim or disagree with it? Well, for this scenario, you would want to disagree. These 2 forces act on the same object. Notice both act on the block. Newton's third law compares forces that act on separate objects, so we would need to analyze one force that acts on the block and another force that acts on a different object. The block is touching the table, so maybe the next step for us would be to focus on the table and figure out what forces act on it. Here, looking at a force diagram for the table, I can think of 3 forces that act. We have an upward normal force provided by the floor. I'll call that Fn2. A downward normal force provided by the bottom face of the block. I'll call that Fn3. And a downward force of gravity on the table by Earth. I'll call that Fg2. Since this table is not moving up or down, we want to say the total upward force is equal to the total downward force. So this equation is just stating that mathematically. This is saying these forces are equal because of the lack of motion, but again, not because of Newton's third law. All of these forces act on the same object. So now we put these force diagrams in the same world. The blue forces act on the block, and the orange forces act on the table. Newton's third law of motion states that one of the blue forces is equal in magnitude and opposite in direction to one of the orange forces. Can you figure out which 2 forces adhere to the law? In this problem, the interacting objects are the block and the table. Let's call them object A and B. We're looking for the statement on A by B versus on B by A. Fn1 is on the block by the table, so I'm looking for something that is on the table by the block. That would be Fn3. So if you flip around the on by notation, that will help give away the Newton third law pair, and I would select these 2 as equal in size, and you can already see that they are opposite in direction. If you want to practice what was covered in this video, you can check out the video description. I have linked my Newton's third law of motion worksheet, which contains a few multiple choice questions. You can find the answers to those questions at the end of the worksheet. If you found this video helpful, then I have other resources that you may be interested in as well. For more information, check out my website, shoot me an email, or follow me on X and Facebook. All of the links can be found in the video description.